For Science Quickly, I'm Meg Duff. Last week, if you missed it, I was up in Harvard Forest learning about a hidden economy. Underneath our feet, plants and fungi are constantly trading carbon and nutrients. Trees use carbon as currency to trade with fungi. Scientists have figured out that they can watch this nutrient economy in action by reading the chemical signatures in the leaves of trees. Those signatures help predict what's going on in the soil, where trees trade with mycorrhizal fungi through their roots. Next, scientists are planning to get that underground fungi data from space using satellites.
We will be able to immediately know what does mycorrhizae look like in the whole planet, which is pretty exciting.
That's Renato Braguiere, a climate scientist who models how carbon cycles through forests. These modeling advances are super exciting.
We could start asking questions about, are these mycorrhizal types actually shifting in space as we predicted?
On one level, we already know what these models will show us.
We are expecting that the system will crash because the system will change, or the conditions for this symbiotic relationship will change in the near future in terms of environmental conditions and also the locations of the planet that they are.
Because we keep burning fossil fuels and adding extra carbon to the atmosphere, plants are starting to experience inflation. If their nutrient economy slows down, forests won't be able to pull as much carbon out of the atmosphere. That means we have less leeway to keep adding it.
I think if we add more data into it, we'll have a better answer in terms of certainty, but not a better answer in terms of the time we have to take action and actually limit our carbon emissions.
Renato isn't super optimistic about our ability to limit emissions quickly.
But I'm just a climate scientist. I'm very, we're not very optimistic with the future just because of what our models tells us.
Can climate models actually help us to change our behavior? That's not a question about scientific advancements, but about human decision-making. To look for answers, I reached out to a climate scientist who, amazingly enough, is still a little bit hopeful.
Okay, I am Regina Rodrigues. I am a professor of physical oceanography and climate in Federal University of Santa Catarina, southern Brazil.
And that's her Westie dog, Whiskey, barking at the monkeys.
He hates the monkeys, to be honest. He barks a lot. He's a terrier. When they come to the garden to steal our tangerines, actually it's time now for the tangerines, and they already came last Tuesday for a visit, and my dog doesn't like that.
Regina lives next to a forest reserve. But unlike at Harvard Forest, no one here has mapped the relationship between all the trees and their mycorrhizal fungi. The funding just isn't there.
Brazil doesn't have the money to invest in research that will not bring an immediately obvious benefit to society. It's much more difficult to sponsor blue sky research.
But Regina is determined and may eventually be able to map and study this forest and forests like it from space by combining data from satellites with machine learning.
Here in Brazil, we don't have too much data, but maybe machine learning can help, artificial intelligence of any kind can actually help to extrapolate this information.
Today's global climate models simulate the whole world, but each pixel is about the size of Rhode Island. Without better local data, local policymakers have frustratingly limited insight, and global projections are full of uncertainty. To solve for those limitations, researchers are turning to satellite data to make some amazing breakthroughs. Looking under the soil from space is just the beginning. Modelers are also tracking the changing colors in Saharan dust, the species of plankton in sea spray, and the daily rates of photosynthesis, literally watching forests breathe. Essentially, they are trying to model everything.
This is a new frontier that we wanted to get to with modeling. Is this digital Earth is basically simulate Earth in a computer model, mimic Earth in all aspects. The idea of having that working is that eventually, say a policymaker wants to make a decision about something, and it can go to this digital Earth and experiment to it and choose pathways of, say, climate change, and what is the outcome. If I choose, say, less emission, for instance, what it will be the outcome of that. That's the ultimate goal.
Regina works with the World Climate Research Program, which coordinates climate modeling worldwide. And she thinks these advances are exciting. She told me that more accurate models could really help with decision-making eventually. But she also has doubts.
I don't think we have the time to wait 7 more years or 10 more years to get a better model. But if that's going to take so long, and in this time a lot of people are going to be affected and maybe even lose their lives.
She's also worried about access.
This information is such a form that is so complex that only us scientists can have access. That is no use, you see. It's exciting that we are in this frontier now, but there is a bad side to it because it's expensive. It ends up leaving a lot of people out of the equation. This information sometimes is not available for who need it most, and this is a big problem.
A lot of people trying to make climate decisions, Regina told me, don't have the training or resources to use the data we already have.
I would say information for short-term decision are very important now. In my town, we have floods, we have extratropical cyclones, but the authorities and the communities don't have this data available for taking the better decision and deal with these problems in a better way. So we needed to develop things that are simpler and more accessible. We needed to just make this information useful and available to the people that matter.
In the short term, she says, we already know enough to act. But scientists need to be better at getting local decision makers the information they need.
If the small thing can deliver now, maybe the information that we have, we can use it as best we can.
The problem is, that's not necessarily how scientists are trained to think.
But it's not that let's say, prestigious to do this type of science. As a scientist, we are trained to always looking for the cutting edge, right?
Scientists are trained to chase discoveries and advances, not to slow down and train end users. So Regina has been thinking about a paradigm shift. And the metaphor she keeps coming back to is a metaphor about mycorrhizal fungi and trees. Big science, she says, with its fancy, cutting-edge models, is like the tree. Like trees collect energy from the sun, these projects collect attention and funding.
But sometimes it's much more prestigious, the above ground, the majestic trunk of trees, the money, the sun. But I guess we need both, and that's what we are trying to do, is the below ground, the network, the small is beautiful.
At the World Climate Research Program, Regina is working on an initiative to create local climate hubs. She imagines these hubs trading information with researchers like mycorrhizal fungi trade with trees. They can use data from big science to make good decisions while also feeding back insights.
In my town, if these people that work with very little resource, but they can actually use the information, learn a little bit with us and vice versa, then we can help them and they can help us to help them.
One example she gave was of a hub of researchers working across borders in the Himalayan region. They're using advanced climate models to coordinate emergency response around glacial floods, despite all the political tensions in the region.
China, India, Pakistan, Nepal, Tibet. And we know that in a higher level, these countries, particularly in that region, are very delicate.
But when local leaders collaborate on emergency response, she says,
these differences disappear in that level. It's not that complicated, see?
Regina hopes that if more local people have information that can help them adapt to the impact of climate change, that could also translate into more grassroots pressure to reduce emissions. She's more optimistic about that approach than she is about solutions where scientists try to convince world leaders directly.
Mitigation is more high level because it's something that all the countries have to agree and do it. It will not work if just one or two countries do it, and everybody has to do it. And this, I'm not seeing the progress that we need to happen, and that is what concerns me, and that's why I'm optimistic that this other way, the bottom up, is the best way.
To Regina, good climate decision-making is less about gathering perfect data and more about using the data we already have. Any access to climate models and data training at the local level should support action and inspire change. Maybe building out this metaphorical mycorrhizal network of climate hubs will help pressure politicians to limit emissions, thereby fixing the inflation problem in the real-world plant-fungi economy. But whether or not Regina's work can have that impact, she hopes it will at least help communities adapt, keeping people safer in the short term.
From that point on, they actually managed to get the climate information that they need and make that climate information useful to improve the lives of people, reduce vulnerability of the people, or increase their resilience to climate change and the impacts. And if we can spread this and have these hubs everywhere and this actually improve the lives of people, that would be the success, you know.
Science Quickly is produced by Tulika Bose, Jeff Delvicio, and Kelso Harper. Music is by Dominic Smith. You can listen to Science Quickly wherever you get your podcasts. Don't forget to go to scientificamerican.com to get the most up-to-date and in-depth science news. For Science Quickly, I'm Meg Duff.